Okay, in terms of the types of questions, they're all, each one of these, it's about 1/3 for each, about 1/3 each. So procedural questions, what these are is maybe a definition, it's recognizing which are the same or different. Conceptual questions are ones where you compare, contrast, find out which one doesn't make sense in the list. And the other third is problem-solving questions. So these might be word problems or application questions. Okay, so they're about 1/3 of each. In terms of the types of questions that you're going to have, tonight we're working on functions, which is rational functions. That's what we're working on tonight. That's about half of the exam. So about 1/2 of the exam is rationals, sine, polynomials, exponents, and logs. Okay, about 1/3 of the exam is your probability. So that's going to be like your counting methods, permutation combinations. And then we have the last section, which is your logic puzzles and your set theory, which are your Venn diagrams. Okay, so that's what is going to be covered on the diploma and the weighting of each one. Okay, so just some tips about the diploma, okay? When you get the diploma, I don't want you to start with the first question and then just go all the way through. I want you to actually look at the whole diploma, and you don't have to start at question 1. I want you to start on the section that you feel the most confident. So start answering questions in your strongest unit. So everybody has a unit that they are the best at. That's the unit I want you to start with. Okay? Now, when you're going through, just a couple of general tips here. First of all, you have 6 hours, so take your time. There is no rush. I have never seen anyone need more than 6 hours for the math diploma, okay? Your first instinct is usually the right one, so only change it unless you are sure it's wrong, okay? So usually the one you choose first is the one you should go with, unless you have made a mistake and you have something to kind of back that up. Okay, this one here is really important. If you don't know the answer within the first minute or so of doing a question, skip it and move on to the next one. Don't spend all your time on one question if you can't get it, because you're going to start to make the same kind of mistake over and over. So sometimes it's best to walk away and then just come back to the question later. Okay, multiple choice, just some tips for multiple choice. Always look to eliminate options that don't make any sense and narrow your good options down. So I always like to cross off the ones that just don't make any sense, just so I can focus my interest and my, choices on 1 or 2. Look for repeated values. Like if you have in all of the options, except for one of them, there seems to be the number 2, chances are that's part of the answer. Look for options that stick out. Those usually are not the answer. So, you know, you have 3 of them that are the same and then one that just really sticks out. That's usually not the answer, okay? I am going to talk to you a lot about this, especially tonight, using your calculator to check or validate the options. A lot of questions are calculator questions, and the 30-2 diploma has calculator questions on it. So calculator questions, I call them gifts. They are gifts. So don't spend lots of time doing a question for 1 mark when you can just put it into the calculator. So when I'm teaching you diploma prep, I'm going to be teaching those tips and tricks to you. Okay? Numeric response. You have to start at the leftmost box and work your way to the right. So for example, if I wanted to enter the number 12, I would not do that. That's not right. I would not write it like that. That would be wrong. I would write it like this. start at the left box and then write it like that. That would be correct. Okay. The decimal gets its own box. That's really important. The decimal gets its own box, and answers will never be negative. So you can't put a negative in there. And then the last one, I don't have it written down here, but the answer will always fit in the box. So if you get an answer and you need extra boxes, that means that your answer isn't right. It will always fit there. Okay? Written response, we talked about that. This is really important. Do not use any abbreviations. Yes, Addie has a question. Can you put the decimal inside the box? And the answer is yes. So for example, you could do something like this. Let me just change my pen color. It would be like 1. Oh, hold on, it's not writing. So 1. Oh, I think I chose the color white. Yes, I did. Okay, let's try that again. 1.2, like that. So the decimal does get its own box. Okay, do not use abbreviations because your teacher is not marking this. So don't use abbreviations, use full words, okay? And then just reread the question when you're done, just to make sure that you have answered all the parts of the question. Very important. Okay. Those are some of the words that you can see on the diploma. I can let you read over those and what they mean. All of these words will always be bolded in the written response. So I have a list of them there that you can look at to see what they mean, okay? Just common sense things that you can bring into the diploma, your graphing calculator, pencils, erasers. You cannot bring in any electronic devices. So you can't bring in your cell phone or anything else like that, okay? Okay, so what we're gonna do in this 30-2, we're gonna review some of the concepts. Consider it a refresher course, okay? I'm not gonna go back and reteach absolutely everything. I'm just gonna kind of refresh your memory about it and then practice questions. This is the most important, okay? So we do not have time to cover every question in your materials. So I am going to cover the most important ones, but I want you to always come back and finish any questions that we don't do, okay? And then when we're working, when we have work period, really important that you guys are gonna ask me for help during any of the work periods. So when we have a break, I'm going to be sitting at my computer and I can check to see, because there's like a little flashing light when I have a message, and I can always answer your questions, okay? Okay, so let's start into our very first topic, which is going to be factoring. And here we go. Factoring, so I have all in your notes, you have the curriculum objectives. Now this is interesting because there are some questions, about 80% of questions are at the acceptable standard. And students always ask me, what does that mean, acceptable? Well, you can look over this. This is the list of all the things that are considered acceptable standards. And about 20% of the questions on the diploma are the standard of excellence. And so you can see there, just like a little bit of an extra step that you have to do. So something that I do want to mention, because sometimes I know students have teachers that don't follow the curriculum. So as your diploma prep instructor, I want to teach you what is on the curriculum, because that's all that will be on the diploma, okay? So something that I want to note is we will only do one operation on rational expressions. So you will never see a question where it is adding and subtracting or multiplying and adding. It's only one at a time, okay? So quadratics can be solved using a variety of methods. You don't have to factor, it's just one of your choices. So you have the choice between using factoring or the quadratic formula. You don't have to use one or the other, okay? Okay, let's look at factoring. So I am on page 11 of your books, okay? So factoring in 30-2 comes down to one of two things. It's either going to be greatest common factor or it's going to be difference of squares. Those are the two types of factoring that we do. So I just want to review with you greatest common factor. So the greatest common factor, I always want you to look for this first. It's the very first thing that you look for, okay? So to look for a greatest common factor, you want to find a number that goes into both the numbers. So there's two types of greatest common factor. One is the number, the other is the variable. So there is a way to do greatest common factor on your calculator, okay? So if you ever wanted to know the greatest common factor between two numbers, here's the steps you can do on your calculator. You go into Math, go to Number, option 9, greatest common factor or denominator, and then separate the two numbers by a comma. So for example, greatest common factor of 12 and 45 is 3. Okay, I'll show you how to do this on your calculator in a minute. And then the other greatest common factor is the variable. So the greatest common factor of two variables is the common variable with the smallest exponent. Let me show you an example of that. If I want to find the greatest common factor of x cubed and x squared. First thing is, it's a common variable. So see how they both have x's? So I know my greatest common factor is going to be x, and I look and it's the smallest exponent. So if you look between these ones here, this one here is the smallest exponent. So the GCF will be x squared. Okay? Once we find the greatest common factor, we can just divide the terms by the greatest common factor. Okay, so let's go ahead and try. Okay, so the first one, I want to factor the following completely. So I need to look at the greatest common factor between 2 and 8. So I'm just going to show you on the calculator, just in case you didn't know that, how to do that. So I'll pull up my graphing calculator. There we are. Okay. Okay, so what I'm going to do is I'm going to go Math. So here's my Math button right here under Alpha, Math. I'm going to go over to Number. So you can see down here my steps that I'm doing, Math, and then arrow, and I'm going to choose option number 9, which is greatest common denominator. So then I'm going to enter in 2, 8, and close my bracket. Okay, so that would give us our greatest common factor or denominator. Okay, so let's go back here. Okay, so I know that the greatest common factor between 2 and 8 is 2. Let's look at the greatest common factor between a exponent 4 and a. So it has to be common, and it is the smaller of the two. So see how there's a 4 here and an invisible 1? It's just 2 to the 1. So altogether, the greatest common factor is 2 and a. And I'm going to write that outside my brackets. When I factor, it's like I'm dividing both by 2a. So I have 2 divided by 2, gone. 4 take away 1 is 3a cubed, plus 8 divided by 2 is 4, and a divided by a is gone. So that would be my final answer, 2a times a cubed plus 4. Okay, let me know in the chat box how we're doing. Is this making sense to you guys? Factoring with greatest common factor. Just let me know how you're doing, and I'll go on to the next one here. Good. Good, excellent. Okay, let's look at the next one. Greatest common factor between 5 and 10. Notice I didn't say negative, just 5 and 10. So the greatest common factor is 5. And then the greatest common factor between x cubed and there is no x is just x. So there's no x. So we don't even have to worry about that because it's not common to both. So I'm just going to focus on the 5. So I put the 5 outside, and then I will divide each by 5. That's gone. Minus 10 divided by 5, 2. Okay, I'm going to try one more, and then I'm going to get you guys to try some on your own. So let's look at here, 7 and 35. So greatest common factor of 7 and 35 is 7. Greatest common factor between W5 and W2 is W, and then I choose the smaller of the two, which is 2. So I'm going to write 7W squared on the outside. So divide them each. So 7 divided by 7, gone. 5 take away 3, 5 take away 2 is 3. 35 divided by 7 is 5. And 2 take away 2 is none, so I'm just left with 5. Okay, I'm going to give you guys 3 minutes to factor these 3 that remain, and then we will compare answers. Okay, so I just kind of started to set this up a little bit here. So for C, I want the greatest common factor between 32 and 24 is 8. But I do notice that both of these are negative. So I'm actually going to take out a negative 8 because both of these here are negative. And then GCF between y squared and y is y. So again, what I'm doing is I'm dividing both by the GCF. So negative 32 divided by negative 8 is positive 4. 2 take away 1 is 1 for the y. Negative 24 divided by negative 8 is positive 3, and the y's cancel. Okay, for the next one, GCF is 5. So take out a 5 and a d squared. So I'll divide each by 5d squared. So 10 divided by 5 is 2. D squared divided by d squared is gone. Minus 15 divided by 5 is 3. And 3 take away 1 is just d. And then the last one, I said the GCF is 2 and d. So I'm going to divide each by 2d. So 10 divided by 2 is 5. 7 take away 1 is 6. Plus 2 divided by 2 is 1, and the d's also cancel. Okay? So I kind of like to take my time with factoring because factoring really is the foundation for all of the rationals. If you can factor, it makes the rest of rationals a lot easier. So let's look at the second type of factoring that you do, and that is called difference of squares. Okay? So for a difference of squares, first thing is, just look at exactly what it says. Difference means subtract. Let me just write that a little differently. So difference means subtract. And squares, that just means they are perfect squares. So perfect squares are numbers that have two identical factors. Okay? So a difference of squares. So it's going to be two perfect squares subtracted. So all we have to do is take the square root of the first term, put it in the first number, the square root of the last term, put it in each number, add one set and subtract the other. So I could write it as minus plus or a plus b, a minus b. It doesn't matter the order, one or the other. Okay, now if you've forgotten what perfect squares are, you can definitely list them into your calculator. You can go into y1 and enter in x squared, and then if you go into your table, it lists out all of the perfect squares. The other option that you can do is just take the square root and see if it's a whole number. So I'll show you that on the next one. Okay. So other thing that I want to refresh your memory on is when you take the square root of a variable. So if I take the square root of a variable raised to an exponent, let me just say here. So variable raised to an exponent. If I take the square root of that, the answer is going to be variable to the exponent divided by 2. So that's not in your notes, but I would definitely write that down. Okay, so the square root of a variable is, variable to the exponent is equal to the variable to the exponent divided by 2. So we'll use these two things to be able to factor difference of squares. Okay, let's try some examples. So first one, here's what I go through and I check. First of all, is there a GCF? Okay, so because there is an imaginary 1 in front of there, that means that there's no GCF. Okay, whenever there's a 1 in front. So I'm going to check to see, do I have perfect squares? So x squared is a perfect square because when I take the square root, it's going to be x to the exponent divided by 2, which is just x. So that just equals x. So that's a perfect square. And then I'm also going to check 36. When I take the square root of 36, it's 6, which means it is also a perfect square. Okay? Numbers that are not a perfect square aren't nice numbers. Let me show you a quick example of that on the calculator. So if I go into my calculator and I do the square root of 36, it's a perfect square because it's a nice number, 6. Okay, let's do the square root of 38, for example. And you see how that's not a nice number? Because 38 is not a perfect square. That's how I can tell. Okay, so what I've established is that both of them are perfect squares. So I can go ahead and factor them. So to factor them, I take the square root of my first term, x, the square root of my last term, 6, add 1, subtract the other. And then I'm done. Okay? Let's look at the next one. Okay, so first thing I would do myself, if I wasn't too sure, I would check, is there a GCF between 4 and 49? And actually the GCF is 1, so there is no GCF. Okay, second thing is I'm going to check to see if these are perfect squares. So the square root of 4 is 2, so I'm good. The square root of 49 is 7, so I'm also good. And the square root of n squared is just n to the 2 divided by 2 is 1. So it looks like I have all perfect squares, so I'm good to go. So let's factor that. So the square root of 4 we said was 2, and the square root of n squared is n. So I have 2n and 2n. The square root of 49 we said was 7, so I put a 7 there, and then I just add one set and subtract the other. Okay? I'm going to do one more with you, and then I'll get you to try some. So always start with GCF first. So the GCF of 36 and 4 is 4. So I need to start there first. So let's take a 4 out, which just means I divide each by 4. So 36 divided by 4, 9k squared, minus 4 divided by 4 is 1. Okay, let's just check on the side here. The square root of 9 is 3, so we're good. The square root of k squared is k, so we're good. And the square root of 1 is 1. So we're good on all of those. So let's go ahead and factor it. So the square root of 9 is 3. Uh-oh, hold on, I'm running out of battery. I just have to pause it right there or we're going to crash. Maybe you guys can finish that off while I'm plugging in so I don't lose you. Okay. Okay, I forgot the #1 rule about teaching online. Make sure you have internet. Got it? Battery? Ooh, I didn't have it. Now we're all good. Okay. So, square root of 9 is 3. So 3 goes in the first. Square root of k squared is k. That's also in the first. And then the last one, the square root of 1 is 1. So I add one set and subtract the other. And now it's factored. So I'm going to give you guys 4 minutes to factor the last ones, D, E, and F. So give those a try and we'll compare answers. Okay, so let's finish these ones off here. So again, I'm going to start with the greatest common factor. I always check that first. So GCF of 196 and 144 is 4. So if you guys don't like to do that by hand, you can use the graphing calculator to help you. Don't forget that. So I'll divide each by 4, and I get 4 on the outside, and then it's 49n squared minus 36. So whenever I have two things that are subtracted, I just want to check if they are perfect squares. So square root of 49 is 7. The square root of n squared is n. Square root of 36 is 6, so I'm good to go. So don't forget to keep the 4 on the outside. The square root of 49 is 7, and the square root of n squared is n. And then square root of 36 is 6 and 6, and I add 1 and subtract the other. Okay, next question. GCF of 6 and 8 is 2, but there's also a GCF of m squared and m, which is m. So don't forget the variables at the same time. So I'm going to divide both by 2m. So 2m on the outside. 6 divided by 2 is 3. 2 take away 1 is m, minus 8 divided by 2 is 4. M divided by m is 1. So I have two terms. So again, I just want to check to make sure that they're both perfect squares. So if you check, the square root of 3 is not a nice number. Let's look. So if I do the square root of 3, see, it's an ugly number, just like the one I showed you before. So that means 3 is not a perfect square, which means I cannot factor this by difference of squares. Okay? So I can say that 3 is not equal to a perfect square. So that means this is as far as you can go. That's it. Okay? Last one. GCF between 20 and 45 is 5. So I'll take a 5 out. Then I have 4a squared minus 9. And then again I check. Square root of 4 is 2. Square root of a squared is a. Square root of 9 is 3. So I'm good to go. First number is 2 and a. Second number is 3. Add 1, subtract the other. Okay, give me a little message in the chat box. Type to me how you're doing on factoring. How's the factoring looking? Like, is it better than it was before, I hope?